So good morning. Good morning from my side as well. I'm very happy that we have so many people here. We have doubled our attendance from last year. So I would like to thank you very much for joining in here. And I will explain a little bit our hypothesis why configuration is such a hot topic, why we really increasing the scope of this topic in many companies and across the whole industry. I have some statements here which are coming from our experience, which are derived from our experience with various projects, and I think they show and shed a certain light on some of the challenges we jointly have when we're talking about configuration. I start with the upper right. Let's see whether I have here a beamer. No, sorry. I start with the upper right side here. Is there? Yeah. After the first pilot project, much more people understand configuration. We have the situation that it's very good to start a pilot project, and sometimes configuration still seems to be a secret, difficult, complex topic to explain to the full audience who needs to sign for a project approval. Sometimes it's really easier to start a small pilot project and show it for some specific product, for some specific machine, and then much more people understand it, and then everybody says, yeah, that's what I wanted anytime, all the time, always. So then you have much more supporters. So we realized in many companies it was difficult to get a full-blown configuration project started right away because people were not sure what are they really doing and what is the goal of the whole thing. This also, we have also a lot of customers who say that they originally underestimated the number of processes which they could improve with configuration. So they started very small, and after they have started and implemented successfully, they then had many more ideas in other business units where to transfer the same concept. So the range of configurable products is much larger than originally assumed. Many people are saying, no, configuration is not a topic for me. This is all engineered to order. We have not any configured to order elements. And sometimes it changes during a project, which is a very good sign. We have also the topic which is sometimes difficult, again, with to talk about with CFOs, let's put it this way, because we have on one hand side, we have a huge savings potential, but on the other hand, we also require huge investment in the beginning. We need to change a lot of internal processes. There is a lot of time required in many configuration projects to get started, to set up all the data appropriately, to set all the rules appropriately, to talk to all the guys to get the knowledge from the engineer's head into the system so that we automate the processes. So sometimes it takes really quite some time investment till we have the benefits. But if we go this way, then we have in many cases very huge benefits. And when we can count the benefits across the whole organization, they are in many cases larger than originally assumed. The problem on configuration, another problem, we don't say problem, the challenge of configuration sometimes is that the savings lie between the different departments. So it's not in production alone, the savings, or in engineering alone. It's the whole process where you have less errors. But who then gets the benefit for less errors in the machine? So sometimes you have really the savings in the overall process rather than in an individual department. We also have a lot of challenge in many projects because you have some internal change management to be done. Sometimes processes really have to be changed if you want to have a consistent configuration. Sometimes sales is no longer allowed to do all this detailing of projects to sell something which might be difficult to engineer because you need to tell sales, well, you are only allowed to tell what we can really configure. And only in very exceptional cases, you are allowed to have additional engineer-to-order functionality. And it's difficult because sometimes in some companies we have a very strong sales force who just sells whatever is possible and is not asking how expensive or how much engineering effort there is, because sometimes it's also difficult to estimate the engineering effort right ahead of time. Another topic is the famous word Industry 4.0 or digitization. The more we want to automate processes, the more we want to automatically have a machine produce a certain product or a certain element, the more we need to configure. Industry 4.0 and digitization really requires a lot of configuration, because you cannot automate processes in the factory if not all the elements, all the data, all the rules, how to do it are somewhere properly documented. So maybe that's also because we are now, maybe that's also a reason why we are now double as many participants this year than last year, because configuration is now really pushed by Industry 4.0, and everybody who thinks of digital processes realizes that he needs also to think more about configuration. Then we have, of course, the topic of configuration. If we want to sell and scale complex products on a worldwide basis, it's very difficult, especially when you sell complex products. In one country, sometimes you can have a good pre-sales guy who can really do this engineer to order, but if you want to sell on a worldwide basis, then it's much easier if some of the work is automated, because you cannot build up these experts with all the knowledge in her head which products fit together to a final product on a worldwide basis. So this means that configuration is also a must to stay competitive in the mid and in the long term. And what we also see is that as many departments are involved, and as the huge benefit of configuration not comes just from, for example, electrical engineering department, but from the whole process, configuration is a topic for top management. And therefore we always advise to involve top management early enough. And I'm very happy that we have now many projects together with you and your customers with real top management involvement. And I'm also very happy that we have now more configuration aspects also in the consumer goods area, because this makes it easier for everybody to understand the benefits. You know, My Muesli, for example, where you can configure privately the different nuts and raisins in a certain muesli. This is also a configuration process. And as many more people are challenged in the consumer goods area with configuration processes, I think it's also easier to sell configuration in the B2B area in our businesses, and not only for our kids and in the B2C area. So I think this is gives a flavor about the topics we have seen in many companies. Maybe it's different in your company. Maybe you have some additional topics, some learnings from your first projects. But generally speaking, to those of you who have looked at the Ritter configuration system yesterday, who have been in Haiger, many of these points were also coming up. Yeah? I remember when we started the project together with Ritter 3 years ago, we had to really fight and really convince so many people that this is the right way to go. And after we have been successful with the first AE cabinet, Ritter cabinet, then everybody was saying, well, it was my previous idea already to do this in this way. And so everybody was then supportive after we had the first success, but it was a very difficult start 3 years ago. Well, let's go a little bit back to the topics I would like to present shortly for those of you who don't Eplan, one slide about Eplan. Then I go into our Eplan strategy and relate back to configuration topics. And then I'll give a short summary to hand over to our next keynote speaker. So for those of you who don't know us, we are Eplan and Cidion are sister companies, and they together form the Ritter software group with more than 1,100 employees worldwide. So Eplan has around 800 and Cidion has around 300 employees. We are present in more than 50 countries with 19 languages, and we belong to the Friedhelm Loh Group, privately owned. This is the owner, 71-year-old Dr. Loh. We are happy on one hand side, that's why I wrote it, that we got the award as top employer, but I guess we're facing the same issue that you are facing. We are urgently looking also for electrical engineers, for people who support us in our growth. We have many open positions, so anytime you hear from an interesting candidate, we are always interested in people to support our growth on a German and on a worldwide basis. Eplan strategy. I like this slide also because it also is for me a good introduction for configuration. Configuration has a very important aspect, which is the lot size one or segment of one, or I don't know, each company calls it differently. In former times when we looked at the project, it was important that we are in time, that we finish in time, that we do not overrun the cost, and that we also have the right quality. Now the customers consider it more and more important to have really a very specific product just for them. They would like a very specific product just produced for them. And if we have a lot size one, if a customer demands a very specific product and not a mass product, and also with our cars, when we buy a car, we get much more in this lot size one. There are more and more options. If you configure a car in the internet, you need really some time to get through the configuration tool until you finish. There are so many questions about, and then questions which exclude each other and so on. So everybody wants a very specific car, a very specific machine. And this is only possible if we have a well-designed configuration process, because otherwise you have 1,000 individual processes, and with configuration you can at least master maybe a high percentage of these individual customers without changing all the processes around. So that was the first topic. The second topic is, what are our three strategic levers at Eplan and Cidion? What are three topics which are relevant for our business at the moment? And this is what we at the moment see as overarching, as pivotal topics coming from our customer base. And all of them are related, and I'll come later to that, in some way, more or less also to configuration. The first topic is the topic of mechatronics. So 5 years ago, 7 years ago, when we received a request for proposal from our customers, then it was maybe only focused on electrical and controls engineering. Or for Cidion side, only on mechanical engineering. Or for, I don't know, Siemens side or Beckhoff, only on PLC software engineering. Now we have many, many more requests for proposals where the whole story of mechatronics becomes more and more important, where you demanding an interface to PDM, where there is mechatronical processes, where there is communication necessary. So nobody, at the moment, there is a high trend to move much more engineering work to agile mechatronical teams. So that's one trend. I'll come back to it later. The second topic is a similar topic, but along the value chain. Again, when we look 5 years ago, and we were, as Eplan or as CDON, asked for appropriate tool, for appropriate software support, we were focusing on savings within the engineering department. So the question was, how can Eplan help reduce engineering costs? How can Eplan help optimize the engineering process? Now we have much more questions being asked. How can we optimize the overall process? Maybe in engineering, it's necessary to spend 10 hours more in engineering, but then be in the production department 20 or 30 hours faster. So sometimes we really have more time in one department and much less time in the other, still with overall savings. Our feeling is that in many cases, we need and we should spend more engineering time in order to optimize the other topics. So it's difficult, it's sometimes a difficult discussion internally, but there are many topics we can do in engineering good so that we have a much shorter production assembly time, or we have a shorter and faster service. Especially on the service, I feel that there will be still coming many topics in the future, how to better service a machine with a little bit more engineering hours. And in a typical time life cycle evaluation, a lot of costs of a machine builder or of somebody who runs a machine are in the operations and service, because this is the long term. Sometimes the machines run for 10 years, for 20 years. And if you can save time there, maybe it's really worthwhile spending a little bit more in engineering. But this is coming more and more, and we see more and more looking outside of the engineering department. And last but not least, the third biggest trend we see everywhere is data. Data. We need more and more data to optimize all these processes. So data consistency is data collection, right data, single source of truth. All these topics are really becoming more and more relevant in the future. And unfortunately, it's also sometimes very tedious and very cumbersome to clean up all the data which have been grown in a typical environment. And it's delaying. Sometimes the wrong data or inconsistent data are also delaying savings to reach in this area, to reach in this area or to reach in this area. So cleaning up data is almost a homework which needs to be done in many companies to set the basis to realize savings in the other two areas. So let's now go a little bit deeper into each of the three topics. First topic of mechatronic. So configuration from our point of view is also a mechatronic topic. So not maybe in the first step, but in the second step, it's really, questions should really be how to ensure joint parametric configuration across different disciplines. So not only for electrical, but also for fluid, for mechanical, for SPS. The big savings are coming if we are combining the disciplines. It's not the first step in many companies, but it's for sure a second step and should for sure be a vision from our point of view for many companies. So the question is how to configure mechatronics components jointly. So again, configuration, we can do it in the electrical, in the mechanical, and on the SPS PLC side. But ideally, in the long term, we would do it jointly. We would define joint mechatronic components and then jointly configure it. This is a high, maybe for some companies a very high goal. But I think it's still good to discuss it and to see, is this the same vision, or is maybe for your company this topic for the next 5 years sufficient? But what we see is, if we try it, it's again a lot of work, but if we try it, we have more savings when we are looking at the different engineering disciplines. I also would like to mention that we have released a new product called Syngineer, which supports the communication between the different engineering disciplines. So we have, this is a tool, we'll not talk about it in detail, but anybody who would like to get more information, of course, should just approach us. We have developed plug-ins for different software packages so that the electrical engineers can communicate better, even if they are using different CAD systems. For example, the user of SolidWorks or the user of Solid Edge or the user of Inventor can communicate with the Eplan user via plugins, or can communicate with the Codesys user on the PLC software side, and they can exchange information about joint mechatronic components. They can exchange information who has changed a component so that the other one gets the right information, because sometimes maybe this guy decides he needs a different switch, which has then also different screws to be fixed in a machine, but this guy does not know it. And so we have developed and released a tool which ensures real-time communication and an interdisciplinary collaboration between the different systems. It's now, as I said, it's now available for, on the mechanical side, for SolidWorks, for Inventor, and for PTC Creo. The next topic is the value chain, and I was talking a minute before about many savings which are maybe coming from other departments. You have seen yesterday the virtual cabinet design from the Ritter example. We also have here Rockwell as a customer who also uses it for their cabinet design. So the idea is that you're not only doing the electric P8 electric schematic, but that you're also doing 3D panel layout. And if you're doing also a 3D panel layout, you can optimize and shorten the time for production and assembly significantly, for production and assembly of cabinets. For example, you can also show the worker then with augmented reality topics where to route the wires, as you have seen it yesterday in the Innovation Center. So this is a good example where more work is done in the engineering. So the engineering is not finished by giving a 2D electrical schematic to the shop floor and then let the shop floor figure out how to wire a cabinet. But here there's more time spent in engineering to also do a virtual cabinet design, because then the guy in the production on the shop floor gets much, much better information. Does not need to be maybe an electrical engineer to understand the complex 2D schematics, but then he exactly sees which component where to put and how to wire from one Beckhoff controller to a Siemens switch or to a Phoenix contact terminal or whatever. So again, you're putting maybe 10 more hours here for doing the virtual cabinet design in Eplan Pro Panel, but then you're saving 20 or 30 hours in the production side because everything is easier to be done. Maybe you can also use, some of our customers saying, you can also use lower skilled workers. At the moment, they need on the shop floor people who really understand complex 2D schematics. And what I see as a future topic is when we are as Eplan working on this already, when we connect also the maintenance processes to the engineering, there could also be even more savings. So at the moment we have shown on the last Hannover fair, we have shown a scenario with SICK sensors and one with a Mur electronics controller, where within the Eplan tool we were listening via OPC UA to the error messages of a potential SICK controller or of a Mur controller, and then exactly on in the Eplan schematic on page 37, then it was shown as a red sign that this component produced an error. So when we are standardizing the languages, and Eplan considers OPC UA to be one potential world standard like Automation ML or like E-Class, which we are strongly focusing upon. So if these standards are developing further, then I'm sure that we can get a better linkage also from the engineering to the maintenance. At the moment, in many companies, after the engineering, a PDF is produced, and then the PDF is shipped to the customer, and then the customer only uses the PDF for maintenance. And in only a few cases, he really uses the full capabilities of an engineering tool to also do the maintenance. And once again, configuration is a topic which makes it interesting, which makes it says we have a high savings potential, but also which makes it a little bit complicated, which goes across the whole life cycle of a product. So the commercial and mechatronic configuration really starts at the customer side, at the sales process, because there we want to configure an order for the customer. And then we go into engineering. We want to configure then a schematic or a mechanical design. Then we go to the production. We want to send the configuration to a machine so that the machine automatically starts producing the right topic. So that's why we really see that, and it goes even to logistics and to the operations again. That's why configuration is a really company-wide approach. However, we need to start it somewhere, and engineering, of course, is a very good starting point. I think you know this, but I always like this slide because it shows very nicely. It's a little bit theoretical, but it shows very nicely where the effect is. So we, via configuration, we shrink the time until we go into operations. So we're saving throughput time on one hand side. We gain some concrete time. The second topic is we have the product defined in an earlier stage. So if you look at the red bar, this is how much the product scope is defined. If you have a normal process without configuration, you have going back and forth, and the product is defined in a much later stage. Here we have it much earlier defined, so we have therefore less errors, less loops, and that's why we are saving a lot of time. So we saving throughput time, we're saving engineering time, and we're increasing the quality. If you do a business case, you really should look at all three effects. Sometimes one effect is more important. For one company, it may be more important that they are faster in finishing. For another company, it's more important that they save engineering hours. So they're reducing the number of hours. And for the other company, it's more important to have a quality improvement. So if you're doing a business case on configuration, you really should look at all three aspects of the game. Yes, you have seen it yesterday. For those of you who haven't seen it yesterday in the Ritter Innovation Center, Ritter is not only our big sister company with 11,500 employees, it's also a customer of Eplan, of the Eplan configuration. They have shown the process where you have, if you go on the Ritter homepage, you can really configure a cabinet with all the Ritter articles like lamp, like cooling equipment, like power supply. So you can combine your electrical, your cabinet, your Ritter cabinet with a lot of Ritter components. And it was a huge effort for Ritter to define all these rules, which components, which filter fits to which cabinet. I was thinking in the beginning it's very easy, but they have then, there are rules. You cannot go with the filter too much on the rim, on the edge of the cabinet, because then you cannot drill the holes properly, so you have to have a certain distance. You can only combine one filter with one cabinet, and not all filters fit to all the cabinets. So there is a really different set of rules. They had also one, I was very surprised, they had a handle. I like to always tell this story because it's so funny. They had a handle to open the Ritter cabinet, and everybody was saying this is a very easy rule. The question is where to drill the holes for the handle to open it or to close it. So everybody thinks it's very easy, but then they found out, well, they have four or five different handles that they use. They have, of course, different holes, M4, M5, and some are somehow differently fixed. Then they have different cabinets where you can have to have a certain edge from a certain distance from the edge. So this position, then the height was again another position. So they ended up with a 5-page rule set until they have found out how complex really it is to put the easy thing of how to, which screws for a handle to put this in a computer. Normally it was easy because if you do it on the shop floor, you just position it and then you make the holes exactly where you have, because you have your handle in your hand and you have the cabinet on the other side, so you exactly know where to make the holes. But if you want to have a standard process about all different sorts of handles, about all different sorts of cabinets, then you have suddenly a very complex rule set. What we ended up to do at Ritter is we reduced the number of handles, of course. Then it was also easier to write the rules, but it was still a big topic. Well, SAP integration, and I'm talking about SAP because we are, in many cases, we start the process here with the sales and not with the engineering. So SAP integration, and we are in Germany in a big SAP country, but similarly we also do it, of course, with other solutions. We have one breakout session where we're talking about SAP integration. So of course we can integrate to the current configuration information LOVC from SAP. But SAP is also now doing a completely new, some of you might have heard it, a completely new variant configuration tool. They are developing a new variant configuration on S/4HANA basis and have a very good advanced timetable. So they are spending really a lot of development resources on also on the configuration, because SAP has many processes where they're also touching configuration, like production, like sales, like maintenance. And we are very happy that we are in a very close contact to seamlessly integrate also our EEC solution into the SAP landscape, so that we have a potential potentially ideal fit from the engineering side to the big SAP solution when it's going to be released. Last topic for the strategy, which is very relevant for us, is the topic of data. Data are the necessary fuel for the 21st century, some people are saying, and we have the feeling that the focus on data is really enormously increasing. Once again, when we, for example, I'll take this example again, when we want to automatically have the rules how to fix a handle or how to fix any component somewhere, we need all the drilling information. We need the drilling patterns, for example, for this component. If we want to put a Siemens switch or a Rockwell controller somewhere, we need to not only know how the electrical macro is looking like, we also need to know how the geometrical dimension of this component is and exactly where are the drilling patterns. Otherwise, a robot cannot drill the holes in the right position. So when we were asking our component providers for some generic data on electrical macros, each month almost, we need to go back to our component suppliers and say, dear component supplier, now we have a new idea for the process. We now want to calculate also the heat dissipation, or we want also to calculate the hotspots in a cabinet. But the calculation only runs properly if you also provide the information about how much Verlustleistung, how much dissipation, how much heat dissipation for this component, for each component is used, and where the heat, in which direction the heat goes off from your component. So then we're asking the poor component suppliers again, now for all your 20,000 components you already have in the data portal, now we need these 3 additional fields so that our final customers, the engineers, can really proper use it and also use the functionality how to calculate the heat dissipation and the hotspots in a cabinet. That's only an example together with our sister Ritter. How the data they have now left our mine in Norway. There are some guys here from Nordics. There is a big mine where they have now big data centers in the underground, where this is a truck. So this is the truck going, and this is all underground. So it's all in an old mine, and they can put thousands of data there, terabytes and of data in 60 meters below ground with a high-level monitoring and access control, just to give an example how much the need of data is increasing also in our B2B area. And here a glimpse from our Eplan data portal from last year, end of last year to end of this year. The number of suppliers who provide their components in our Eplan data portal has jumped from 171 to 261, so a huge increase. And also the number of downloads goes steadily up, and more people. 5 years ago, it was you only needed maybe a picture of a component to put it somewhere and an electrical macro. Now, as you need all this information, it's not possible anymore for a customer to really research all the data himself in the net. If he uses a GE component, if he uses whatever component, he cannot research all the data himself in the net. He would like, and that's why it's so popular, he would like to really drag and drop within his Eplan environment all the necessary data so that it's much faster for him to build up a schematic. So this was it a little bit with talking about strategy and talking about all the relevance to configuration. So we were talking about Mechatronics, the cooperation between electrical engineers, mechanical engineers, and software engineers, where we think that configuration should also have a goal to really incorporate the different dimensions. Then we have talked about the integrated value chain, not only look at engineering, but look at where the process is started in sales and how it goes to the different departments. Configuration, again, is an overall topic. And then PDM, smart data, however you call it, the high relevance of good data, of good structured data for a proper configuration process in order to drive the whole thing. So I have made 5 statements and you may be able to add some more from your own experience, and some are also a little bit visionary. Our goal somehow is to have a complete, we are never complete, but this is a vision, a complete virtual product development with complete virtual representation of the machine, so that you really do not learn anything more from live operations. This will never happen in this 100% way, but we are going step by step. So we have at least the most surprising learnings we can anticipate by a virtual twin or by a virtual representation. Then a second goal, which cannot be reached again, but which is, I think, also a good vision, a good asymptote to look at, is ideally we would have, for the lot size 1, which I mentioned in the beginning, would have the same price for the customer as with a mass serial production. This will also never happen, but if we have a complete configuration process for a robot, at the end of the day, it doesn't matter so much whether he drills 100 times the same hole pattern or whether he drills 100 different hole patterns somewhere. Because for him, for a robot, it's almost the same type of work if everything is automized. So the more we automate, the more we can shrink the difference between cost of lot size 1 and mass production. Then ideally we would use all the engineering data throughout the complete product life cycle instead of only within different engineering or other disciplines. So that's why we are talking more and more about the digital twin. And the digital twin should not only be a digital engineering twin or a digital production twin, it should be a digital twin which goes through the whole life cycle where you really look not only in one specific phase of the product, but where you look at the whole life cycle, which topics, which entities, how individual each component is. Then we have also a topic where we are not in a greenfield environment. There is, at least to our knowledge, not a single company who can provide everything around configuration. Even the big companies we have in the world cannot do the whole thing. We need a network, we need data, we need this software, we need that software. So it's always a way of partnering, what we see in the industry, partnering between different machine builders, partnering with Google, partnering with SAP, partnering with other Microsoft cloud platform providers. So these topics are no longer a topic where we can do just on ourselves with one provider. And sometimes the cultural change of these topics, and I guess you know better examples than I do here from your own company, is often the biggest challenge and not the technical representations, the technical realization. Sometimes we are faster with one solution, what we can offer, than the change internally. So I think there is a lot to do. It's the right direction, and the many people, to end here with my introductory statement, who are here show that we are really here at the hot spot. Let's join forces in this direction. Also, please use what Achim already said in the introduction. Take the time to talk to each other. You will find many experiences from other people here on this big round. So have fun, and thank you very much for listening.